Welcome to Physics with Technology. You should be watching this video on Monday, March 19th. There will be times during the video where I ask to pause, so if you are the substitute teacher, if you could just listen, and when I ask to pause, please do so that the students have time to work through some of the examples on their own. We're going to be starting today by taking a quiz. So students, you need to take out your lab books and open to your quiz section. Today's quiz is called the First Law Quiz. If you are the substitute, please pause the video now so that the students have time to work through these questions. When the class is ready, you can restart the video and the quiz will continue. Here is the next set of quiz questions. Once again, if you are the substitute, can you please pause the video so that students have time to work? And when the class is ready, you can restart the video and continue. Okay, we are going to grade the quiz now. Can you please trade your lab books with other people at your table? You should not be grading your own quiz. It's too tempting to give yourself extra points. So here are the answers to the first 4 questions. If a word is red, it means that the question was false, and that word is what was supposed to be written. If there's not a red word, it means that the original statement was true. So if you're the sub, can you please pause now so that students can look at the answers? When the class is ready, you can restart the video. Here is the answer to questions 5 through 8. On questions 7 and 8, the student doesn't have to have the exact same answer, but they should be using inertia and the ideas we discussed with Newton's first law as part of their answer. They can't say something vague like, the seatbelt helps you stop. I need something a little more detailed than that. So once again, please pause the video so that students have time to grade, and then you can restart. All right, now we are going to start the new lesson for the day. In your note packet, you want to turn to the day labeled Forces, and we're going to be learning how to identify and draw force diagrams because this will really help us as we continue to learn the rest of Newton's laws. So once again, students, you need to have your note packet out and you should be taking notes. This is the day labeled Forces. What is the force? We all know the answer to that. The force is this magical energy that permeates the universe and binds us together. I'm just kidding. That's what Star Wars says the force is, but we're not actually talking about the force today. We're just talking about what is a force. So in physics, the word force is any push or pull exerted between 2 objects. So make sure you write that down in your notes. Anytime you feel a push or a pull, it means that the universe is trying to force you to do something. Now, these forces can come in 2 different varieties. The first category is called a contact force. A contact force is when objects actually touch each other. So if you've ever been punched in the face, then you have felt a contact force. There are sports that we call contact sports, and that's because the players physically touch each other while they're playing, and they can often be very dangerous because it's easy to get injured. The second category is called field force, and a field force is a force that acts from a distance. The objects aren't actually touching. A good example of this is gravity. Gravity can reach up into an apple tree, grab the apple, and pull it down, even though the apple wasn't touching the ground. And if you think about it, that's actually really strange. How can a force reach across empty space and grab another object? It really starts to feel like this is the Force from Star Wars when they just hold out their hand and they pull a lightsaber from a distance. Science is actually still not entirely sure how field forces work. There are different theories, but it still is a bit of a mystery. We're going to look now at a list of common forces, and you want to learn the letters that we abbreviate with, as well as write down some of the concepts as I discuss them in your note packet, so that you'll remember the rules for what these forces are and how we draw them correctly. The first one we're going to talk about is a capital W. This letter represents weight. It's the most common force we see in force diagrams because it's really hard to get away from planet Earth, which is always pulling you down. We learned last time that there's a formula for weight. You multiply mass times gravity. So on planet Earth, that just means you're going to multiply the mass of the object by 10. Now, what is weight exactly? If I was defining it, then weight is the force of gravity pulling an object toward the Earth. And you do want to write that down. When we draw weight in a force diagram, the rule is that weight always points straight down. It's actually pointing towards the center of the Earth. Gravity is Mother Earth finding nearby objects and trying to bring them home by pulling them down towards the core. In order to escape Earth's gravity, you have to go really, really far away into space, and that's unlikely for you to ever do in your lifetime. The next force is a lowercase n. It represents the normal force, and the normal force is what prevents solid objects from going inside each other. If you've ever been walking and not paying attention and you have run into something like a wall or a door or a pole, then you've encountered the normal force. Basically, the atoms in the pole tell the atoms in your body that they are not allowed to enter. And so you end up with a big bruise because physical objects are not allowed to go inside each other. I like to think of this force as being the Gandalf force. If you've seen Lord of the Rings, there's a famous scene where Gandalf is facing a large monster and he tells the monster, "You shall not pass." Well, this is what happens when a solid tries to go inside another solid. The atoms at the surface stand up and they resist and they say, "You shall not pass." The rule for drawing the normal force is that it should always be perpendicular to the surface that provided it. Remember that perpendicular means that it should form a 90-degree angle or a perfect corner. This is actually where the name normal force comes from. In math, the word normal means perpendicular, and this force is always perpendicular to the surface that provided it. The next force is a capital T. It stands for tension. Tension is a pulling force. The rule for tension is that it is always parallel to the pulling element. So whatever object is doing the pulling, this could be a rope or a chain or a handle, but the arrow for the force is going to follow that handle. So in this case, we have a swing with two ropes, and those ropes are pulling the seat up. Notice that the arrows follow the ropes. If the ropes had been angled, then my arrows would have angled to make sure they followed the direction of the rope. The next letter is a capital C. This stands for compression. Compression is a pushing force. Notice there is a spring on the page. The original spring is very tall, but you can force a spring to go smaller by compressing it. If this happens, the spring doesn't like it. It wants to go back to its original shape, and so it will push, trying to return to the shape it wants to be. The rule for compression is that it is always opposite to the compressed element. What that means, in this picture, the spring was compressed in the downward direction, and so it's actually going to push back in the upward direction. If you placed a tennis ball on top of this spring, it's going to push the ball up as it tries to return to its natural shape. The next force is a lowercase f. It does matter that it's lowercase because we're going to see that the capital F is used for something different. Lowercase f is friction. Friction is what prevents solid objects from sliding past each other easily. If you have ever experienced a carpet burn or road rash, then you've experienced friction firsthand. It can hurt when your body slides across the cement because friction is trying to stop your motion. The rule for friction is that it is always parallel to the surface and opposite to the direction of sliding. So in this picture, there's a little boy being pulled on a sled. Notice that friction is parallel to the snow, but it's pointing in the opposite direction that the boy is facing. So his parents are pulling him forward and friction is trying to stop him, so it points backwards. Friction is a very common force, and it's one that it's hard to get rid of, even if you try. The next force is a capital R. Capital R is resistance. Resistance is what prevents solid objects from moving through other substances easily. If you've ever tried running across a swimming pool, then you've experienced water resistance. It is really hard to run in a pool because the water is stopping you every step you take. In this picture, I have someone who is skydiving and they've opened their parachute. The rule for resistance is that it always points opposite to the current velocity. This skydiver is moving in the downward direction, and so air resistance is going to push the parachute up. This resistance is what slows the descent of the diver and saves their life. If you went skydiving on the moon, then you would die because there is no air on the moon, and so there would be no air resistance. Even if you brought a parachute and tried to open it, nothing would happen. You would just keep falling in free fall until you hit the ground. The next letter is a capital F, and we use this for other forces. Basically, any other force that doesn't fit our categories gets a capital F. The rule for other forces is that the arrow should point whatever direction makes sense. In my picture, I have a rocket that is using its thrusters to push itself into the sky. The red arrow represents the thrust of the rocket, and we don't really have a letter that we've already learned about that represents rocket thrusters, and so we would use a capital F.